Once again, welcome to today's class. Today we are going to be looking at the distance between two coordinates and the midpoint of a line. Eventually, we will have to extend the bit into some of angles between lines, between slope, angle between slope, or angle of a slope, and angle between lines. If time be, we will then extend it a bit further, but for now, that's what I'm going to be looking at. So, I did said once the recent class that given a Cartesian plane where I have my y-axis and my x-axis and my coordinates and my origin 0, 0, then when I draw a straight line, and which I call the shortest distance between the 2 points, let's say point A and point B, that's the shortest distance on that Cartesian plane, I just labeled it. The way to know the distance between these 2 points is something easy to do. You know that normally this particular point is galvanized by a particular coordinate, and it still go on and on because it maps up with this place as well, and there's also a coordinate here. So if you check it, it is forming a what? It's forming a kind of right angle triangle, whereby there's an angle here, but we have no business with that angle at this moment. We can call the distance between this point A and point B, we can call it R. Do you understand? And if here is our x1 and here is our x2, the 2 points on the x-axis, and if here is our y1, which also is same thing as this place, our y1, and definitely this particular point is our y2, which also in turn will be our y2 here, then these two, the distance between these 2 points will be y2 minus y1, and the distance between these 2 points will simply be what? x2 minus x1. So that we're going to be having a triangle that looks like as of this form. Here is my r, here is my x2 minus x1, and here is my y2 minus y1. Do you understand? And then there's an angle here, even though we have no business with that angle at this moment. Then I'm going to apply that our popular Pythagoras theorem that states that what? Hypotenuse squared is equals to what? Opposite squared plus what? Adjacent squared. What's my hypotenuse? R squared. Opposite. Then is my y2 minus y1 squared plus my x2 minus x1 squared. Then eventually, what do I have? Eventually, what do I have? I'm going to be having r square root both sides. The square root of what? Of y2 minus y1 squared plus x2 minus x1 squared, which can in turn be written as the square root of what? X2 minus x1 squared, then y2 minus y1 squared. So this is the equation, this is the distance between 2 points of a line. How be it if I want to know the midpoint, the center point of this line, I mean the very, very midpoint of this line, as touching these two guys, then what do you observe? You observe that these 2 points, the midpoint of this line, will obviously fall at the midpoint of x1 and x2. And the midpoint of this line will obviously fall at the midpoint of y1 and y2. And by the process of linear mode, which we also have the video in our one of the clips in our archive, you will discover that to get this midpoint means I will add this plus this together to get this midpoint. That is to say, y1 plus y2 over 2 will give me this midpoint, and this midpoint will be given by x2 plus x1 over 2. So that the midpoint of a line, the midpoint of a line of coordinate what? Of coordinates, say, x1, y1 and x2, y2 will be given as what? NP, midpoint, x2 plus x1 over 2, then y2 plus y1 over 2. That is how we get the midpoint of a line. It's that easy. So the moment you can locate your, are you with me? The moment you can locate your, what am I saying now? Your coordinates, it's easy to know the midpoint and the distance between the points. Now let me now make a very good reference to my theta, which is my angle. Now don't forget, okay, I'm going to do that at the end of the class when I'm done gathering my thoughts. That the angle of a slope, in a way, the angle of a slope, is simply if I have a Cartesian plane once again, such that I have a line that extends in this way, and don't forget, what's an angle? An angle is that which is formed when two or more lines meet. There's no angle is not formed when two lines do not meet. So when two or more lines meet at a point, a particular angle is formed. So since this line is intersecting with this line, there's an angle that is formed called angle theta. But how can I decode this angle theta? This angle theta is simply defined and known by saying that my tan theta, you understand, is equals to m. You ask me, how do I know that theta is m? Do you remember that tan theta is opposite over hypotenuse in our popular trigonometry ratio, 2 opposite hypotenuse? And for this triangle I have drawn, here is my opposite, here is my hypotenuse, and here is my adjacent. Meaning that tan is opposite, meaning that what? Tan theta is opposite, which is y2 minus y1, and adjacent is what? x2 minus x1. And if you remember, I told you in our last class that remember that our slope is y2 minus y1 over what? x2 minus x1. What does that imply? It implies that tan theta is equals to m. So theta is equals to tan arc inverse of m, the second function of tan of m. That is how you can know the angle that is between this line and the x-axis that is forming our theta. But if I am dealing with two or more lines, maybe I have two lines or more line on the graph, so that I have a line of this form and I have a line of this form, and I want to know the angle that is formed in between them. There are several methods of knowing that, you understand, of getting that angle, but one way I believe you can know it without stress is to say the angle formed between this line, let us say line L1 and line L2, here is our theta. Don't forget that this our guy we have, so in other words, this is our line L1, we have a slope of M1, and our line L2, we have a slope of M2. So by the intersection, our theta with tan theta equals to M2 minus M1 over 1 plus M2 or M1 times M2, though is the modulus of this guy will give us our tan theta. Do you understand? But I can as well say that I can also find it in respect to our angle of line L1 and make it to the x, angle of line L2 and make it to the x, and subtract and have an answer. But I believe this is one of the best ways that you can easily solve the question without having headaches. So I'm going to take two examples, one like just only one, to pinpoint each of these facts on board. Though I may not come to this place, I may just end my adventure here, but I want you to understand and follow the train of thought that I'm trying to come across to you. Let's consider these following examples. We are given two coordinates. Let's say we are given two coordinates. Say coordinates 2, 3 and coordinates 5, 4 as the case may be. And we are given coordinates -1, -2 and 3, 2. This is the coordinates. And we are asked to solve for one, the distance between the 2 points or the two coordinates, distance between the two coordinates. You understand? The two coordinates. Then we have got 2. I am asked to solve for the slope. Let me say slope now. I'm going to do that. The midpoint of the coordinates. Do you understand? Then the angle. The angle of the slope, or with the slope, as the case may be. Do you understand? What if you want to solve this? The last one I gave to you is not applicable yet, except I give you the equation of a straight line, and you look for the slope of the first line and the slope of the second line, and you simply impute this into that formula, you'll be verified. Do you understand? So look at this now. Number 1, I'm giving 2, 3, and I'm giving 5, 4, and here's my x1, y1, x2, y2, And distance between the coordinates, don't forget that is from my figure 1, r is the square root of what? X2 minus x1 squared, and my square root is extended, not this way. And you say, not that way, math is very sensitive. So I have y2 minus y1 squared. You also tweak it, like put x1 and x2 here, because you can never have a negative number. Square root is help. So r is then equals to square root of, where's my x2? 5. Where's my x1? 2 squared. What is my y2? 4. What is my y1? 3 squared. So the distance is simply equals to what? 3 squared plus 1 squared. And that is equals to 9 plus 1, which equals to the root of 10. Answer. That will be the distance between the 2 points. You can look at your calculator, you have 3.1 something as your answer. But the same coordinate, I'm asked to solve for my midpoint. How do I solve my midpoint? The midpoint is simply what? X2 plus x1 over 2, then followed by what? Y2 plus y1 over 2. If that is the case, what is my x2? My x2 is simply 5, my x1 is 2 all over 2. What is my y2? My y2 is 4, my y1 is what? 3 all over 2. Then it becomes 7 over 2, 7 over 2 as my answer. You can as well go further and say 3.5 and 3.5, it makes no difference. It's still the midpoint of your line without stressing yourself as it were. Then the angle between the slope, meaning that, let me first solve my slope. Don't forget my slope is what? Y2 minus y1 over what? X2 minus x1. This is the formula for the slope. So what's my y2? My y2 is simply 4 minus 3. What is my x2? My x2 is 5 minus what? 2. And that is 1 over 3. So don't forget the angle between slope is what on the line? Tan theta of m. So theta is equals to tan arc inverse of 1 over 3, which equals to what? Tan arc inverse of 0.3333. So punch your calculator, then you have an answer eventually when you punch your calculator. The second function of tan, 0.3333, is the angle between the line and the slope. So it's something very easy to do the moment you have your heart at it. Follow the example I'm going to do, and I'm sure it suffices for any number of questions you want to do. Then try number 2 for yourself, and if you so wish, drop your answer in the comment section. Let us see what you have as your answer. So once again, thank you for being a part of this class. In our next class, we'll be looking at something else that pertains to this, and I hope to see you then. Or just make sure that you subscribe to this channel and also turn on your notification bell so that you'll be alerted whenever a new video is uploaded. Thank you.